Welcome to Teach Mechanical YouTube channel. Today's topic is types of fluid flow. Types of fluid flow: steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, 1, 2 and 3 dimensional flows. This is a steady and unsteady flow. You see that this is a current situation of flow, the velocity, pressure and density. The density for incompressible fluid is same, but other fluid characteristic like velocity, pressure, density. We go for a compressible flow, consider density. If we go for incompressible flow, don't consider for density. Density is same for incompressible fluid. Here is the current situation and this is a future. Both are same. Okay, velocity and pressure. Okay, that is called as a steady flow. Okay, and unsteady flow, this is a velocity and pressure of current situation, and in future the value is change. Okay, uh, that is called as a unsteady flow. Okay, the fluid characteristic velocity, pressure, density at the changes with respect to time. Okay, next we go for definition. This is a steady flow. A steady flow is defined as the type of flow in which the fluid characteristic like velocity, pressure, density, etc. at a point do not change with time. Thus, for steady flow, mathematically, dou v by dou t equal to 0, dou v by dou t equal to 0, and dou rho by dou t equal to 0. Right? And unsteady flow is the type of flow in which the fluid characteristic like velocity, pressure, density at a point change with respect to time. Okay, change with respect to time. Mathematically it is dou v by dou t not equal to 0 and dou v by dou t not equal to 0. Right, this one. Next, uniform and non-uniform flow. See the diagram. This is an uniform flow. Here the direction of flow is parallel. Okay, each streamline are parallel. Okay, the velocity at any given time does not change with respect to space. Okay, velocity is constant. Right, here the velocity at given time with respect to space. Okay, here see this is a space is different, so the velocity also the different. Right, next we go for definition. Uniform flow, it is defined as the type of flow in which the velocity at a given time does not change with respect to space. Okay, any space the velocity does not change, equal to 0. Okay, t equal to constant and equal to 0. Here the mathematical representation is dou v by dou s, t equal to constant equal to 0. Right, here dou v is change in velocity, dou s is length of flow in direction s. Okay, change in length. Right, next, non-uniform flow is the type of flow in which the velocity at a given time change with respect to space. Mathematically non-uniform flow is dou v by dou s, t equal to constant not equal to 0. Okay, next we go for laminar flow and turbulent flow. This is the laminar flow diagram. Here, this is the laminar flow diagram. Here the fluid particle moves along well-defined path or streamline, and all streamlines are straight and parallel. You see that all the streamlines are straight and parallel to each other. Right, and next we go for turbulent flow. Turbulent flow, fluid particle moves in a zigzag way. See that there is the one fluid particle, so move this direction, is on, and then this direction, and then this direction, and then this direction, like that. Okay, the fluid particle move in a zigzag way due to the movement of fluid particle in zigzag way. right? This is the definition. Laminar flow is defined as the type of flow in which fluid particle moves along well-defined path or streamline, and all the streamlines are straight and parallel. Thus, a fluid particle moves lamina or layer gliding smoothly over the adjacent layer. This type of flow is also called as streamline or viscous flow, right? And then we go for turbulent flow. This is a turbulent flow definition. Uh, Turbulent flow is the type of flow in which the fluid particle moves in a zigzag way. Due to the movement of fluid particle in zigzag way, the eddies formation takes place, which are responsible for high energy loss for a pipe flow. The type of flow is determined by non-dimensional number, that is a Reynolds number, that is called Reynolds number. It is Vd divided by V. Here the capital V means the velocity of the flow, and d is diameter, and small v is kinematic viscosity of fluid. If the Reynolds number is less than 2000, here see that Reynolds number less than 2000, the flow is called laminar. Okay, the value is more than 4000, this is called a turbulent flow. 2000 to 4000, the flow may be laminar or turbulent, right? Next, compressible and incompressible flow. This is a compressible flow. Compressible flow is this is a gaseous flow, gas flow or air, like that. This is a compressible fluid flow. Compressible fluid flow means the volume is changing. Okay, if you are applying pressure, the volume is changing. Okay, that is called as a compressible flow. Yeah, incompressible flow, if applying pressure, the volume is does not change. Okay, is a incompressible flow, right? Is a compressible and incompressible flow definition. Compressible flow is the type of flow in which the density of fluid change from point to point. Okay, uh, if you are applying pressure, the density of compressible fluid is changing, right? That is here mentioned here is density is not constant. Okay, density not equal to constant. If you go for incompressible flow, is the type of flow in which density constant for the fluid flow. Liquid are generally incompressible while gas are compressible. This mathematically incompressible flow density equal to constant here. Okay, density equal to constant. And then next we go for rotational and irrotational flow. The rotational flow is the type of flow in which the fluid particle which flowing along streamline also rotate about their own axis. See this diagram. This is the center point of axis. Okay, flow in a straight line, streamline, right? uh, and then rotational along with the streamline. Okay, that is called as a rotational flow. The irrotational flow is the type of flow in which the fluid particle while flowing along streamlines do not rotate about their own axis. Okay, the fluid particle also follow the streamline axis, but it is not rotating their own axis, right? That is called as a irrotational flow. Next, one time one dimensional and two dimensional and three dimensional flows. One dimensional means the title itself is says that the flow direction is only one direction. So u equal to function of x. Here the flow particle moves in x direction only, so yz is absent. So where u v w are the velocity component of x y z direction. Here see the xy and z direction respectively. So u of fx means u equal to function of x, v equal to function of y. Here the v is absent, the y is absent, so v equal to 0 and w equal to 0. That is called as a one dimensional flow. We go for two dimensional flow. The fluid particle movement in two direction, x and y. So u equal to function of x and y, v equal to function of x and y. Okay, w equal to 0, there is no z movement, so w equal to 0 is called as a two-dimensional flow. After that you go for three-dimensional flow. Here three dimensions x, y, z. Okay, x direction, fluid particle move x direction and y direction and z direction. U equal to, so u equal to function of x, y, z, v equal to function of x, y, z, and w equal to function of x, y, z. Okay, so three dimensional flow is the flow direction in three axis. Okay, x, y, and z direction, right? Thank you, thanks for watching.